Great, last 5. Right, let's look at these. Let's go. So we have this company. Just a couple of things that I wanted you to pick up here. You almost kind of have to watch this carefully. I had to read it a couple of times as well just to settle, because I was on the train when I did this particular bunch of 5. The standard cost for Z is £5 per hour, is £200. I don't know if the way it is, but in effect, what they're really telling you that to make product Z, you needed 40 hours. That was the message here. £5 an hour, £200 or £40. Just 40 hours. That was the first thing, and that's what they've assumed. That's their plan. But we know that it's possible that as you make more, to make the second unit, it won't be 40 hours. It'll fall generally. But generally, this is the assumption, if you like, when you're planning and making these products. You just have this standard variable cost fixed, no changing. We're saying that's not quite true. So what is the following statements about labor variance analysis is true? Costs are not a factor to consider. That's just ridiculous. All labor variances should be investigated. Small, you don't have to investigate them. So 1 and 2 gone. So 1 and 2 gone. 1 gone. 2 gone, leaving you 3 and 4. But anyway, implementing a JIT will affect labor efficiency. That is true. And because, right, the faster, less time, it will change everything. JIT moves into automation, so it will definitely affect it. Reliability of figures as a factor to consider when it should be investigated. Yeah, I mean, how well can you trust the figures or the standards that you're starting with? So it's just it's a natural hazard you want to be aware of. So 3 and 4 definitely correct. So the answer is D. Let's jump into this. This is our favorite learning curve story. So here, what are they telling us? They're telling us that you currently believe that it'll take 40 hours to make this thing. And standard, before we did learning curves, we would have said 40 hours to make a unit. Therefore, 200 units, 8,000 hours. They're telling us, actually, we can actually help you out. We can tell you what the learning curve rate is, and we can actually tell you how many hours it actually takes to make 200 units. And using our equation, if I can find out what the average time is, I'll say that again, average time is to make 200 units, well, I can find out what the total time it is to make 200 units. So if I can find out, if I know that y is equal to a, where a is equal to 40 hours, which is the time it takes to make the first unit, times 200 raised to the power of b, where b is equal to the log of 0.9 over the log of 2. So I need to kind of find this, and I think this comes out to minus 0.2 something something something. So I then need to, when I found this, which is log 0.9 over 0.2, I get 0.152. I now need to do 200 raised to this. So I need to do 40 hours times 200 raised to the power of minus 0.152. And then you find the average time to be, you find the average time to be 17.877 hours per unit. So the average time to make 200 units with the learning curve of 90% is 17.887 hours. But if I know what the average time to make a unit is, all I need to do is apply the two together, and I can find the total time, and that comes to 3575 hours. So now I can see that in terms of right at the beginning, this is what they define as a planning variance. Right at the beginning, you thought it was going to be 8 hours. It's actually 3575. And the difference, of course, is the number of hours, what the variance is, which is 4,425 hours. Right? So you have 4,425 hours at £5, which is, they tell us what it is. Right? So now we've been able to kind of fix things, if you like, and we arrive at this figure of 22,125, right? So there we are. So we have a favorable variance of 22,125 because we've kind of fixed this problem, if you like, by now dealing, because because what will happen is that the workers are actually learning, right, and on the job, and they're faster and faster. So you would have thought that it would take you 8,000 hours times £5. This is what you were thinking you were going to spend, but unfortunately you would only have spent 3,575 hours times 5. So you have a favorable variance. You've spent less because you were unaware of that learning learning curve potential. So that means it's favorable. Great. And then from here, I think this is again an application of little things we've been talking about for a while, isn't it? So here they're telling us after 401, it's the same as it took to make the 400th unit. So you're looking for how long did it take to find the 400th unit. So you know that y is equal, if I can find the total time it takes to make 399 units, and I can find the total time it takes to make 400, and I can subtract the 2 to know how long it took to go from 399 to 400, right? So, which means I need to kind of do the equation twice. I need to do y 399 and y 400. So I need to do y is equal to 40 times, if you like, 399 raised to the power of log 9 divided by log 2. Do the same thing. 40 times 400 times log 9 raised to the power of log 2. And then when I get my answers, I believe for this one, the average was 16 for the 400. For 400, my average was 16.0897, and my average for 399 was 16.0958. So these are the averages. Then you need to multiply these by the actual total number of units to find the total time, and you should find that your total time for 400 units was 6435.87, and your total time for 399 units was 6422.22. So now I can find the time it took to make the 400th unit, which comes out at 13.65 minutes. Of course, that's the difference. And they're telling us that for the next 250 units, it's the same thing. So you're literally multiplying 13.65 times 250, and that takes you to A. Cool, great, right. And then let's look at the next one. This is idle time. I thought this was a pretty good question, personally. So they tell you that you had paid for this, and they had only worked this. I mean, it's not absurd. You know, you had expected an idle time of 1050. So you paid for 5250. So and they worked 4500. So they had idle time of 5. Actual idle time was 5. Come on, pen, wake up. Actual idle time was, oops, sorry. Actual idle time was 5250 minus 4,400, which is 750. That was actual idle time, and you expected idle time. So you have a favorable, first of all. So you expected them to just be hanging around for 1050, but they actually hung around or had coffee for 750. So this minus this, if you like, times £5, which is your standard cost, gives you, if you like, this minus this is 300 hours. So 300 times 5 gives you 1,500 favorable. So 29 is C. And then finally, which of the following statements are correct? Planning variances are of more use in a changing industry. That's true. I mean, you know, the fact that things are changing all the time, you separate the two out and know what's actually causing that so you can adjust and use for the future. Will not result in managers changing the assumptions. That's not true. You are actually trying to change and we've just done questions on it. Standard costing is less suited to organizations that make different types of products. Yes, that's true. And I hope this session would have helped you with that. And planning variances do not need to be. That's not true. So really the answer is A. You need to get everything. Cool, great stuff. And we'll discuss, I will make a video for 31, 32, both of them tomorrow morning. Awesome. Please look at these videos. Great stuff. Cheers for you.